Hello students, today we will be solving the IB Math A HL May 2024 paper 3 time zone 2 question number 2. You will be getting the answer for the first question of this paper and solved answers for the other questions from the other papers in form of playlists on my channel NS Online Math Tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. In case you want to join my classes, please contact me for more details. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 2. The maximum mark is 31. This question asks you to find the probability of graphs of randomly generated quadratic functions having a specified number of x-intercepts, that is the zeros. In parts A to F, consider quadratic functions f of x equal to ax square plus bx plus c, where the coefficients a, b and c are randomly generated in turn by rolling an unbiased six-sided die 3 times and reading of the value shown on the uppermost face of the die. For example, rolling a 2, 3 and 5 in turn generates the quadratic function f of x equal to 2x square plus 3x plus 5. Part A's question is explain why there are 216 possible quadratic functions that can be generated using this method. This is containing just a single mark. Okay, so part A's answer, it will be 6 possible outcomes. What are the 6 possible outcomes? 1, 2, 3, 4, 5 and 6. There are 6 sides of an unbiased die. It is said that it is having 6 sides. So there are 6 numbers, 1 to 6, and any of those 6 numbers can be coming on top uppermost face of the dice. So there are 6 possible outcomes. For A, and I'm writing and because just to show that they will get multiplied. Okay, and 6 for B and 6 for C. Okay, therefore total number of, what did they say? Total number of possible quadratic functions. Okay, possible quadratic functions will be 6 times 6 times 6, which is equal to 216. It is paper 3, so you can use your calculator. I know 6 cube is 216. You can use your calculator to find the product. Okay. Okay. So this is explained. Part B, the set of coefficients A equal to 1, B equal to 4 and C equal to 4 is randomly generated to form the quadratic function f of x equal to x square plus 4x plus 4. Verify that this graph of f has only one x-intercept. Okay, it is a quadratic function and its graph will be having only a single x-intercept when its discriminant value will be equal to 0. So, single x-intercept implies discriminant equal to 0. Or b square minus 4ac equal to 0. Okay, so b is what? 4. So let me write, and they have given the b value is 4, so I don't have to write the b value separately again. So b square is 4 square B square is 4 square minus 4 times E is 1 and C is 4. So this is equal to 16 minus 16, which is equal to 0. Therefore, the graph of f of x will have one x-intercept. Okay. By considering the discriminant or otherwise show that the probability of the graph of such a randomly generated quadratic function probability having only one x-intercept is this. This 216 is the total number of outcomes that we have seen in the Sapat E. Now we have to see how many possibilities are there where the quadratic function will be having only a single x-intercept. Okay, so it is C, single x-intercept implies b square minus 4ac equal to 0 or b square equal to 4ac. Okay, that means 4ac is a square number. Therefore, 4ac is a square number. Okay, now let me take the different values, possible values for A and C. Okay, it is containing 6 marks. So let us try. It will be taking some time, but it is an easy question. I am taking the A's value as 1. Okay, so I can take the C's value also as 1. So 4AC and B. So 1 times 1. So 4AC is 4. B will be square root of 4 plus minus 2. B will be positive number, so 2. So this can be taken. Okay, so 1, 2, 2 times 4 is 8, cannot be taken. 1 and 3, this is 12, not a square number. 1, 4, 4 times 4 is 16. So this square root of 16 is 4, so this can be taken. And 1 times 5 cannot be taken. 5 times 4 is 20, cannot be taken. 1 times 6, 6 times 4 is 24, cannot be taken. So now 2 times 1 is 2 and 8 doesn't work. 2 times 2 is 4, 4 times 4 is 16. Yeah, this can be taken. 2 and 2. 4 times 4 is 16. So the B's value is 4. So this can be taken. 2, 3 is 6. 6 times 4 is 24, not a square number. 2 and 4 is 8. 8 times 4 is 32, not a square number. 2 times 5 is 10. Times 4 is 40, not a square number. 2 times 6 is 12. 12 times 4 is 48, again not a square number. Now I come to 3. 3 and 1. 3, A's value is 3 and C's value is 1. So 3 times 1 is 3 times 4 is 12. Not a square number. 3 times 2 is 6. 6 times 4. No. 3 times 3 is 9. 9 times 4 is 36. Yes, this can be taken. 9 times 4 is 36. So this can be taken. Okay, so this is 6. I have got the 4 of them. I should be getting one more. What is that? Oh, I will be having another one as 4, 1. Yeah. Because I know the answer. It has to be 5 over 216. So the favorable outcomes should be 5. I have got 4 of them. So what will be the fifth one? This is 2 and 2. This is 3 and 3. So A and C values are the same. This is the only one where the A and C values are different. So I can take the A value as 4 and the C value as 1. So 4 times 1 is 4 and 4 times 4 is 16 again. So this is 4. So you see, you have shown the what are the five possible cases. Okay. So since there are, I can search for more numbers, but these value will be more than 6. There may be another square number 4ac. I may get another square number for 4ac, but if you square root it, I'll be seeing that b's value is more than 6, but b cannot have a value more than 6. Okay. So since there are 5 possible outcomes for which 4ac is a square number and square root of 4ac is square root of 4ac is greater than or equal to 1 and less than or equal to 6, and square root of 4ac is an integer. Okay, because this is 1 times 2 is 2 times 4 is 8. Square root of 2 is definitely between 1 and 6, but it is not square root of 8 is 2 root 2. It is definitely not an integer. So square root of 4ac has to be between 1 and 6, but it should also be an integer. Okay, so that way we are having 5 possible outcomes. Therefore the probability is 5 over 216, since the total number of outcomes is equal to 216. Okay. Now consider randomly generated quadratic functions whose corresponding graphs have two distinct x-intercepts. That means the discriminant value should be more than 0. So, but this question is fine by considering the discriminant, determine the set of values, possible values of EC, product of A and C, containing 3 marks. Okay, so it is D, discriminant equal to b square minus 4ac should be greater than 0. Implies b square should be greater than 4ac. Okay, maybe E is 1 and C is 1. So 4 times 1 times 1 is 4. We can have b value as 3. So 3 square is 9, which is greater than 4. Let me again get the products of A and C. This is A. Okay, AC and 4AC. Let me write this because b square should be greater than 4AC. So 1, 1, 1. Yes, we have possible. And maximum value, let me write maximum value of b square is 36 because maximum value of b is 6. So maximum value of b square is 36. So as long as we are getting this product 4AC less than 36, we can continue to take. So 1 times 2, we can take 1 times 2 or 2 times 1. Both will be the same. The product is the same, I mean. And this is 8. We can take this. And 3 times, okay, 1 times 2, I have taken 1 times 3. And 3 times 1, 3. And 4 times 3 is 12. 12 is less than 36, we can continue. 1 times 4, 4 times 1, and 4 times 4 is 16, can be taken. 1 times 5, 5 times 1 is 5. 5 times 4 is 20, can be taken. 1, 6, and 6, 1. 6 times 4 is 24, can be taken. Okay. So now let me make another set of columns. EC and 4AC and 4AC. Okay. So now I am taking, I have considered all the ones. So I will not be taking 2, 1. I have taken 2, 1. So I start with 2, 2. The product is 4. I have already considered 4 as the product, but anyway, 4 times 4 is 16. Yeah. So I'm not taking the ones that I have written. 2 times 3 is 6. Have I taken 6? Yeah, I'll not be writing that. So 2 times 4 is 8. Have I taken 8? No. 2 and 4 and 4 and 2. Both give you 8. And 8 times 4 is 32. Okay. And then 2 times 5. 2 times 5 is 10. 10 times 4, 4AC. 10 times 4 is 40, which is more than 36. I cannot take. Same for 2 times 6. 6 is 12. 2 times 6 is 12. 12 times 4 is 48. More than 36, I cannot take. Okay. So same for 3. If you take 3, 3 and 1 is 3. I have got the product as 3. So I'll not be testing that again. 3 times 2 is 6. I have got the product as 6. 3 times 3 is 9. 9 times 4 is 36. It can be taken. 3 times 3 is 9. The AC is 9. And 9 times 4 is 36. But this cannot be taken as well, sorry. Because this should be greater, not equal to. If it is equal to, then the quadratic function will be having only a single x-intercept. So I cannot take the 4AC value as 36. I cannot take this. 3 times 4, 12 cannot be taken. 3 times 5, 6 cannot be taken. So I am seeing as soon as I'm reaching 9, I cannot take 9. So obviously I cannot take the higher products also. So I am having the products, the AC values as 1, 2, 3, 4, 5, 6, 8. I'm not having any 7. Has to be because the factors of 7 will be 1 and 7. And I cannot have the number 7 because there are only 6 sides of it that dies and you don't have the number 7. So I'll not be getting the product as 7 anytime. So I have got the AC values that I need to have. What was the question? Determine the set of possible values of AC. So, therefore, the possible values of AC will be 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5, 6, and 8. Okay. Actually, when I was editing the video recording of this question 2, I found that the microphone did not work for this part E. So I am re-recording this part separately. This part E is having two further subparts. The I is saying for the case where EC equal to 1, we had the function f of x equal to ax square plus bx plus c, and it was said that the condition was there will be two distinct x-intercepts or two distinct solutions of this quadratic function. So for that condition to be met or satisfied, the discriminant should be greater than 0. So discriminant equal to b square minus 4ac should be greater than 0 for two distinct x-intercepts. Okay, or we can write b square is greater than 4ac. Okay, and for part I, it is said that EC equal to 1, so 4AC will be equal to 4 times 1, which is 4. So B square should be greater than 4. Okay, so implies B square is greater than 4 times 1 because AC is 1, or implies B square is greater than 4. Okay, so B square is greater than 4. What values of B can we have? 1, 2, 3, 4, 5 and 6. So 1 square is 1, which is not greater than 4. 2 square is 4, which is equal to 4, not greater than 4. So the B square values will be 9, that is 3 square, 16, which is 4 square, 25, which is 5 square, and 36, which is 6 square. These are the 4 values that can be taken for B square, which are greater than 4. Okay, therefore B will be equal to either 3 or 4 or 5 or 6. Okay, so the EBC, let me write EC equal to 1 and EBC. How can we have EC, the product of E and C equal to 1? When E equal to 1 and C equal to 1, only in that case we will be getting the product as 1. So it is 1 and B can be 3 and 1. Okay, 1, 4, 1, 1, 5, 1 and 1, 6, 1. These are the 4 possibilities. Okay, 4 quadratic functions. So therefore, I can write because it is the first part of this type. So let me write the 4 quadratic functions that we may have. So therefore, the 4 quadratic functions it is containing just a single mark, so you don't have to write all these things in detail, but I'm showing you how are you getting these. So this you have understood. This can be got only when E equal to 1 and C equal to 1. Only then can you have the product as 1. Okay. So 4 quadratic functions are Ex square. So E is 1. So x square plus 3x and C is 1. X square plus 4x plus 1. X square plus 5x plus 1 and x square plus 6x plus 1. These are the four possible quadratic functions having a as 1 and c as 1, and so therefore 4ac will be greater than 3 square, which is 9. In this case 4ac will be 3 square will be greater than 4ac. 9 will be greater than 4. 4ac is always 4 because e is 1 and c is 1. So 4ac is 4, so 9 will be greater than 4, 16 will be greater than 4, 25 will be greater than 4, and 36 will be greater than 4. So these are the four possible quadratic functions. Okay. So shown. Fine. Coming to part I for the case where AC equal to 2, the product is 2. Show that there are 8 quadratic functions whose corresponding graphs have two distinct x-intercepts. Okay. I AC equal to 2 implies E equal to, what are the factors of 2? 1 and 2. Okay. Because the factors, of course, the integer factors, the positive integer factors. And also which are less than 6, less than or equal to 6, but greater than or equal to 1. So E equal to 1 and C equal to 2, or E equal to 2 and C equal to 1. Okay. So therefore 4AC is equal to 4 times 2, which is equal to 8 for two distinct solutions. Distinct x-intercepts. B square should be greater than 4AC. So implies B square should be greater than 8. Therefore, what can be the B square values? B square can be equal to 9, 16, 25 and 36. Okay, same as before for this part I. So implies B values are 3, 4, 5 and 6. Okay, so therefore what can be the combinations of for E, B and C? Let me first of all take E equal to 1 and C equal to 2. So 1, 2 and B is equal to 3. 1, 2, B equal to 4. 1, 2, B equal to 5. 1, 2, B equal to 6. These are the four possible quadratic functions. Okay, it will be, because A is 1, so it will be x squared plus 3x plus 2. This for this, x squared plus 4x plus 2. This way, you will be having the four quadratic functions, f of x. And the other four will be 2, 3, 1. This time, it is E equal to 2 and C equal to 1. So, 2, 3, 1, 2, 4, 1, 2, 5, 1 and 2, 6, 1. Okay. So, these are the 8 possible quadratic functions. Okay. In F, you will be seeing there will be more options given for AC equal to 3, 4, etc. So, for those, I have not written the quadratic functions separately, explicitly, but for these 8 quadratic functions, let me write them. Okay. Just to show you how to write the quadratic functions. We have got the values of A, B and C. So, therefore, the 8 quadratic functions will be functions are, and it was f of x. So, let me write f of x for each of them. and f of x. Okay. And for this one, it is f of x equal to 1, a is 1, so it is x squared plus 3x plus 2, and f of x equal to x squared plus 4x plus 2, f of x equal to x squared plus 5x plus 2, f of x equal to x squared plus 6x plus 2, and now the other 4, f of x equal to, this time e is 2, so it will be 2x squared plus 3x plus 1, f of x equal to 2x squared plus 4x plus 1, f of x equal to 2x squared plus 5x plus 1, and f of x equal to 2x squared plus 6x plus 1. Okay, so these are the 8 quadratic functions that are possible when EC is equal to 2. Okay. Let P be the probability of the graph of such a randomly generated quadratic function having two distinct x-intercepts. So part F is saying using the approach stated in part E, or otherwise find the value of P. Okay, value of P. P be the probability. Okay, so the denominator has to be 216 because total number of outcomes we had seen that to be 216 in part A. This is also containing 6 marks. Okay, so from EI, AC equal to 1, 4 possibilities. Okay, from EII, AC equal to 2, it will be 8 possibilities we have seen. Okay. And from D, we had AC values as 1, 2, 3, 4, 5, 6, and 8 when there are two distinct x-intercepts. Okay. Fine. So now we have got AC equal to 1 and AC equal to 2. We have to find 3, 4, 5, and 6 and 8. Okay. So AC equal to 3. How can you have AC equal to 3? E equal to 1, C equal to 3, or E equal to 3, C equal to 1. This is how you can have the product of A and C as 3. And for two x-intercepts, we should be having B squared is greater than 4AC, implies B squared should be greater than 3 times 4 is 12. So therefore, possible values of B squared will be, it is 16, 25, and 36. Okay, or B equal to 4, 5, and 6. Okay, so we are having, therefore, EBC one, and I'm taking 4, 3, 1, 5, 3, 1, 6, 3 times by 2. Therefore, because I'll be having 3, 4, 1, 3, 5, 1 and 3, 6, 1. Okay. So therefore, 6 possible quadratic functions. Now AC equal to 4. Okay. So how can we get the product of AC as 4? E equal to 1, C equal to 4, or E equal to 4, C equal to 1, or E equal to 2, C equal to 2. Okay. B square minus 4AC is greater than 0 means B square is greater than 4AC, implies B square is greater than, AC is 4, so 4 times 4 is 16. So B square is greater than 16, therefore B square equal to 25 and 36. So implies B equal to 5 and 6. Okay. So now I am having this E, B, C. So it will be 1, 5, 4, 1, 6, 4. Same for this, it will be 4, 5, 1 and 4, 6, 1. And for this, it will be 2, 5, 2 and 2, 6, 2. So this should get multiplied with 3. Therefore, 6 possibilities. Okay. Now AC equal to 5. E equal to 1, C equal to 5. Or E equal to 5, C equal to 1. B square is greater than 4AC, implies B square is greater than 5 times 4 is 20. Therefore, B is equal to, B square can be 25 or 36, so B is equal to 5 and 6. Okay. You will be having what? 1, 5, 5, 1, 6, 5 and 5 and 6 and 5, 6, 1. Okay. So, okay, let me just write ABC 1, 5, 5 and 1, 6, 5 multiplied by 2. So, 4 possibilities. AC equal to 6, E equal to 1, C equal to 6, or E equal to 6, C equal to 1, or E equal to 2, C equal to 3, or E equal to 3, C equal to 2. Okay, you have to just get the possibilities, possible number of ways in which the product of A and C can be equal to 6. Okay, so B square is greater than 4AC, Therefore, b square is greater than 6 times 4 is 24. Therefore, b is equal to b square will be 25 and 36. So, b is equal to 5 and 6 again. Okay. So, ABC, it is 1, 5 and 6. 1, 6, 6 multiplied by 4 options 1, 2, 3 and 4. So 8 possibilities. I am showing you in details. If you want to skip, if you can find the number of possibilities directly, then you write them, but it is containing 6 marks. You have to remember that part also. So if you don't show the working, you write everything in shorts as a short summary, then you don't get full 6 marks. You have to remember that as well. Okay. So AC equal to AC equal to 7 is not there. AC equal to 8. Oh, we have reached the last one. That's very good. 3, 4, 5, 6 and 8. Yeah. So A equal to, I cannot take A equal to 1 and C equal to 8. That is not possible. So I have to go for A equal to 2 and C equal to 4. Or E equal to 4 and C equal to 2. These are the only two ways for getting the product as 8. Okay. Because 3 times 3 is 9. I cannot take 3, 4, 5 or 6 for getting this number 8 product as 8. Okay. So, and b square is greater than 8 times 4 is 32. Therefore, b is equal to only 6. So, we have the values for A, B, C. A is 2, 6, 4 and I am having another as 4, 6, 2. So, these are two possibilities. Okay. So, now we will be adding and therefore, total number of favorable outcomes equal to, this is 2 plus 8 is 10, 10 plus 4 is 14 and plus 6 is 20 and plus 6 is 26, 26 and 8 is 34 and plus 4, 38. Okay. So you have 38 total number of outcomes equal to 216. Therefore, P is equal to 38 over 216. If you want, you can cancel. So this is 1 and 9 and this one is 1 and 0 and 8. So this is our answer for the subpart F. It was a large one, long one. Okay. In subparts G and H, consider a randomly generated quadratic function f of x equal to x square plus 2zx plus 1, where the continuous random variable, it is the standardized continuous random variable, normal random variable, I mean, z, this is a normal variable, normal distribution variable with mean as 0 and the variance as 1. So the standard deviation is also equal to 1. Okay. So part G's question is find the probability that the graph of f has two x-intercepts. Okay. Two x-intercepts again doesn't matter whether we are having that z or not, but the discriminant has to be greater than 0. That is the condition. Okay. So x square plus 2zx plus 1. So let me just write it once more over here. X square plus 2zx plus 1. And z is the standardized normal distribution variable with mean as 0 and the variance as 1. Okay. And we need to have two distinct solutions, x-intercepts. So b square should be greater than 4ac. Therefore, b square is what? 2z, this thing whole square, and is greater than 4ac. So 4 times 1 times 1, which is 4 z square is greater than 4, implies z square is greater than 1, right? So z square is greater than 1 if you think about, you don't have to think about something this as the standardized normal distribution variable right at this moment. You can take it as x square is greater than 1. Okay. And if you just think of, this is paper 3, so you can use the calculator. If it is x square is greater than 1, what is the graph of x square? It will be like this. The vertex will be at the origin and maybe this is 1. Okay. So x square is greater than 1 is what? When x equal to 1, x square is equal to 1, and when x equal to minus 1, then also x square is equal to 1. So this is 1 and this is minus 1. Okay. So this one is x and this one is y. And this is the same thing. Just because you are having a standardized normal distribution variable, it is nothing different. Okay. So you can just have this x square graph. And so when, for which x values do you have x square greater than 1? When x is more than 1 or when x is less than negative 1? So this is x is more than 1. Sorry. Or x is less than negative 1. Okay. So I'll be writing the same thing. Implies z is either more than 1 or z is less than negative 1. Same thing. So, and of course, the normal distribution curve is symmetrical. So the probability of z being more than 1 should be equal to the probability of z being less than negative 1. But you don't have to realize this. You just have your calculator. You find the probability of z being greater than 1 and z being less than 1, negative 1. Okay, this is what you have to get. And you see, they are asking for the probability. Okay, so we have to find the probability of z being greater than 1 and or the probability of z being less than negative 1. So or probability of z less than negative 1. Okay. So I get the calculator. Okay. And another thing that I have to say is, one of my channel viewers was asking me that whether CAS calculator can be used in the IB examination. No, you cannot use the CAS calculator, and this is not the CAS calculator. It is this is TI Inspire CX, it is II, this is CX2 student software. So it is the TI Inspire CX2 calculator that I use. This is not a CAS calculator. Okay. And I have to go to menu, and then it is either the probability or the statistics. I'm choosing the probability, number 5, and then there is the distributions, number 5 again, and it is the normal CDF. Okay, normal CDF, not the normal PDF, normal CDF, so 2. And for P of Z greater than 1, the lower bound is 1, or the other values of Z will be more than 1, so the lower bound is 1. And the upper bound, I can write this as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 nines I have written. And mu is 0 and the standard deviation is 1. Okay, so okay. So this is 0.158655. I am writing 0.158655. So this is equal to 0.158655. And because this is OR, I'll be writing plus. Okay. And then P of Z less than -1. So again, menu and number 5, you can use number 6 also. Number 5 for distribution, number 2 for normal CDF. And then P of Z less than -1. Less than -1 means -1 will be the maximum, the upper bound. Okay, all the other numbers will be less than -1. So upper bound is -1. It is 0.158655. As I had said that this is a symmetrical curve. So you will be having the values the same. So it will be 0.158655. So this is equal to, I can take the answer and multiply by 2. It is 0.3173. Correct to 3 significant figures, I can take 0.317. Okay. Most probably, did they say anything about how many digits do I have to take? No. Okay. Correct to 3 significant figures. Coming to the last subpart of this question, the continuous random variables x1 and x2 represent the x-intercepts of the graph of f, where x1 is equal to -z minus square root of z square minus 1 and x2 equal to -z plus square root of x square z square minus 1. Subpart H is asking for given that means it is a conditional probability question. Given that the graph of f has two x-intercepts, x1 and x2, find the probability that both x1 and x2 are greater than 0.5. It is containing 7 marks. Okay, so, okay, don't just get confused by looking at these two. Many students will be getting confused just by this. Oh my goodness, this standardized normal distribution variable, how did it get introduced to this quadratic function? Okay, so this is the first place where you can get a shock, a very big shock. And this is the next place. So you don't get shocks. How are you getting? If you solve this, I'm showing you. I'm just showing you. It is basically the quadratic formula. Okay. Let me write it once more. So H, it was f of x was equal to x square plus 2zx plus 1. Okay. So if you have to solve for x, x is equal to minus b, which is minus 2z, plus minus square root of 2z whole square minus 4 times 1 times 1. over 2 times 1. Okay. So this is equal to minus 2z plus minus square root of 4z square minus 4 over 2 equal to, I don't know whether I'll be having space, 2z plus minus square root of 4, I'm taking 4 as the common factor, z square minus 1 over 2. Okay. So this is minus 2z and square root of 4 is 2. So plus minus 2 and square root of z square minus 1 over 2. So these two will be getting cancelled with these two 2's, and it is minus z plus minus square root of z square minus 1. So this is basically the two x values, nothing else. Okay, don't get confused. And they have taken x1 equal to minus z minus square root of z square minus 1, and x2, this is x1, this is x2 minus z plus square root of z square minus 1. Okay, you see x1 is having a minus sign over here. X1 is having the minus sign and x2 is having the plus sign. Okay. And given that the graph of f has two x-intercepts. Okay. So the probability that the graph of f has two x-intercepts was found in subpart G, but I have got the answer correct to 3 significant figures. I have to get more number of digits. From G, P of z greater than 1 or P of z less than negative 1 is equal to, I have to get more number of digits. I have written only 0.317, but let me check. It was 0.317 and 3105 I am taking. Okay. After 317, it is 3105. So 317 and 3105. Because whenever you have to use one answer in some further calculation, you have to make sure that you are not taking only 3 significant figures for that future calculation. Okay, you have to take more number of digits. So now they are saying, the question is saying that both x1 and x2 are greater than 0.5. Okay, so P of x1 and x2 greater than 0.5. Okay, so, and you should be obviously converting this to z because it is basically the z expression. So you are having the calculator. Okay, let us take x1. For x1, first of all, let us take x1. Okay, and I'll be graphing this because I have to get the values, range of values rather. So I'll be graphing this, and because I'll be graphing this, I'll be writing x in place of z. Okay, and it is containing 7 marks, so it is better that you show the graph. Why are you saying, why are you giving that as your answer? You have to give the justification. So you draw a rough sketch. Okay, you have to rather draw 2 rough sketches for 2 graphs, x1 and x2. So I go to the graph page and I will be taking x in place of z. So it is minus x, and I'm working for x1, so it is minus, and square root of x square, sorry, that is x and minus 1. Okay, so graph, fine. And I have to get another horizontal line, 0.5. Fine. So 0.5. Enter. So I'm seeing this small portion above this 0.5 line. Okay, let me get the intersection point. intersection with this minus 1.25. So x values, and what is the highest point over here? Let me trace it. I am saying this is minus 1 and this is 1. From the two axis, I think that this point is having coordinates as minus 1 and 1, but let me trace to be sure. Okay, so graph trace, and it is 0 and undefined. Okay, let me just take minus 1.25. I know it is having a certain value. So x equal to negative 1.25 I have taken. So this is the one. And then I am just advancing. This one is minus 0.95. Okay, let me just see what is happening when x equal to negative 1. X equal to negative 1. Yes, you see, this is the topmost point for this graph. And for this branch, it is always below 0.5 level. So we do not have to take this branch. And it is C minus 1 and 1. So you can take the x values. X should be, or Z should be greater than negative 1.025, because when Z is negative 1.25, it is 0.5. It should be greater than negative 1.25, but it can be less than or equal to 1. For this 1, you should be including the equality sign. Okay. So, and you have to draw this. You have to draw this. This is negative 1 and 1, and this one is, okay, let me just draw this rough sketch. Let me do it. Okay, so you see, I have drawn this graph. You see over here, you have to, you don't have to be accurate. You have to just show the shape. There are two branches and it is crossing the 0.5 horizontal line at this point, negative 1.25 comma 0.5, and it is moving up to negative 1 comma 1. Okay, and this is the other branch. So this is for x1. So therefore, and these are the x and y. Because we have graphed, we cannot take z. We have taken x and y. So therefore, the z values will be, z is, it should be greater than negative 1.25, but should be less than or equal to 1. This is for x1. And what is for x2? Let us get the graph for x2 also. It will be a plus sign in between. That is the only difference. Okay. So let us move to this, and I'll be taking another graph sheet, graph page. So it is negative x, and this time it is plus sign in between. And it is x square minus 1. Okay. And you see, and you see over here, this is, you can straight away see this is having the coordinates. This point, the lowest point, the bottommost point from for this branch is 0, negative 1 and 1. You can see the coordinates, read the coordinates at this point. And for this branch, it is never more than 0.5. Obviously, it is below the x-axis. So I will be taking, you have to take all the x values which are less than negative 1. Because this side, if you come to this side, you will not be getting any x values which are more than 0.5. Okay. So from this, you are seeing that x is less than negative 1. So we have to draw this also. Now this is the curve for x2. Again, I could not take z. I have graphed this, so it is this. And again, you are seeing I have to take this branch, and this is the point having coordinates negative 1 comma positive 1. So every point on this graph will be having the y value more than 0.5, and I cannot take this branch at all. So from here, I will be getting that, sorry, this is x is not less than or equal to 1. Sorry, this is x is, z is less than or equal to negative 1. Sorry for that. And from here, I am getting the z value as less than or equal to negative 1. Okay. And I have to get the intersection values for these two, both of them, because x1 should be greater than 0.5 and also x2 should be greater than 0.5. Both have to be met. Okay, therefore the intersection point, so therefore the z values for which x1 is greater than 0.5 and x2 is greater than 0.5 will be between these two values, negative 1.25 and negative 1, because this is having z is less than or equal to negative 1, but I cannot take the z value as negative 2 because that will be less than negative 1.25. So the common interval is this one. So this will be negative 1.25 is less than z is less than or equal to negative 1. So these are the values that we have, z values that we have to take. Okay. Therefore, and we have to get the probability. Negative 1.25 is less than z is less than or equal to z. Negative 1. So this should be equal to, let us find. We move to the calculator page once more and menu, and then okay, this time let me take statistics number 6 and then again number 5 distributions and number 2 normal CDF, and the lower bound is negative 1.25 rather, and the upper bound is negative 1 and mu is 0 and the standard deviation is 1. Okay, so 0.05 3005 0.05 3005, I'm taking up to this. Okay, 0.05 3005, or the next digit was 4, so I can take this 4 also. Okay, so this will be our numerator. Therefore, e of x1 and x2 greater than 0.5 will be equal to, there are two values, two solutions, I mean. So it is a conditional probability 0.053005 divided by, this is the one that I have to take, 0.3173105. Okay, so let us find the value. Okay, and for the upper one I can take the answer, and for the lower one it is 0.317 and 3105. 3105. Enter. So it is 0.167. Up to 3 significant figures, it will be 0.167. Okay. So this is equal to 0.167 correct to 3 significant figures. Okay. So we have completed answering this question number 2. So we have in fact answered the whole paper 3. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. It will be motivating me and it will be telling the YouTube that my videos are worth watching. So it will be increasing my videos reach. You will be helping me and also you will be helping other students. So because the YouTube will be showing my video to more number of students. Okay. And from our next session, we start to solve a new paper. Till then, bye.